Welcome to IP3's CCSK exam preparation module.
Welcome. I'm Ken Kuski, president of IP3. Over the years, I've had an opportunity to discuss emerging technologies and the security threats they introduce to our organizations with you through videos and live workshops. It's been a lot of fun. It's been challenging, interesting, and always stimulating. But what I see today more than ever before is the recursive nature of the threats we're dealing with. We keep coming back to them. We seem to be trapped in these endless loops. And the fundamentals remain the same. These guys, this is my iPad or my Android phone, are fundamental game changers to most consumers. But from an IT security professional's point of view, they're largely the client interface device, the screen and keyboard. I've called these thin clients for over a decade, and I don't know how much different they are than simply a thin client. They're untethered. I don't have to be wired to the Ethernet, so they've got mobility as well. But when we put all of that together, a simple, easy-to-use mobile interface, we've created a much more threatening environment than what we've seen in the past. Because our systems now are accessible, they can be reached by anybody on the net. Now that was true when I was sitting at this desk with a hard terminal wired to the Ethernet, if we allowed open remote connections. And we did allow those. We allowed modem banks to dial in, but we had callbacks. So a typical secure modem bank would take an inbound call, you'd say, let me in, and I'd say, okay, I know your number, I'll call you back, and I'd initiate the connection from within. And the physical phone network gave us a solid, secure audit trail. It was very, very hard to spoof a phone number. You could do it through call forwarding, but that still gave us a physical audit trail to where the message originated. This thin client is different, but it's different because of mobility more than anything else. It's different because now we have to allow an IP data flow into our enterprise from anywhere. Because users don't want to be locked in one location with these. Now, if this is going to be used in a different location, it introduces some other concerns. What about sniffing of the traffic? What about somebody getting possession of my device? We're going to worry about lots and lots of traditional security issues, but we're going to take a fresh look at them in the context of what we call cloud computing. Cloud computing is about the other side of a thin client. The cloud is everything not in or on the thin client. So we've got to worry about how do we think of this as the user interface that is strongly authenticated. And remember, we've always had a problem separating device authentication from user authentication. Cloud just brings back all of the basics. Nothing has motivated a return to the fundamentals in information assurance security than cloud computing. So let's dig into it and take a look.
Cloud computing has been evolving from today's implementation from almost the beginning of the modern computer age. Back in 1960, John McCarthy foretold this powerful, extraordinary concept of cloud computing. Beyond defining the various components of the cloud, which by the way really is just a synonym for the internet, we look at the essential characteristics necessary for a solution to be considered a cloud computing solution. We'll then look at how the cloud is used from a service perspective, and then how the cloud can be deployed for use. There are three different descriptions of cloud computing that are vitally important in understanding what the industry means by cloud computing. The three descriptions we'll use are aligned with the published works of the U.S. National Institute of Standards and Technology, or NIST.
The virtualization and the cloud deployment have created very difficult challenges for security professionals. Two in particular. Transparency, we don't see what happens in a virtual world. It's out there, but we don't get to see it. And accountability. If we can't see it, it's hard to know clearly who's in charge and who's responsible and who's accountable. And so transparency and accountability become real serious concerns for IT security professionals. Nobody confronts this issue more immediately than today's U.S. federal government. No organization has a bigger IT operation in the universe than the U.S. federal government. And the U.S. federal government has turned to the National Institute for Standards and Technologies to provide guidance to the myriad agencies that need to implement cost reductions and improve efficiencies and better service their constituents, us the voters. NIST set as a guideline that they want to implement safe cloud computing. How are we going to do that? Number one, identify our security objectives. What are we trying to protect? How do we expect to protect it? What are the goals? Understand the provider's environment. If we go to salesforce.com and get software as a service, that's one model. And we can understand that model. It might be different than a private cloud that we produce, or it might be different than some very open source types of environments. How do we ensure client-side environments meet our standards and our privacy? We're going to try to drill into that. What can we do to deal with transparency and accountability out there in the cloud? And then how do we maintain accountability over privacy and security?
Cloud computing security controls are not fundamentally different than controls used in other IT environments. Where the controls reside, who manages them, and who is responsible for them does change. What does not change is that the subscriber or consumer is accountable for security. Regardless of the new technology and the new parties involved in your business, you own the assets and you are accountable for providing for their proper protection by ensuring that your business partners conform to your needs or that you take some sort of compensatory action.
So risk management in the cloud is our case to start exploring these ideas. We want to focus on a unique approach to risk assessment driven by T&A. And in risk management, we mean transparency and accountability. That's the most we can ask for as risk management professionals, and that should guide our work to produce transparency and accountability. How do we make the world aware of the new risks we're accepting by choice in our information systems? How do we acknowledge that risk, and who's accountable for that decision process? Both transparency and accountability are threatened by cloud activity. We're breaking down traditional structures that tried to impose transparency and tried to provide a line of accountability to a world where it's not clear at all who's in charge and who's accountable, and there certainly is a loss of transparency in any virtualization exercise. So our struggle is, how do we reintroduce those capabilities? What are the cloud-specific risks that we want to understand and give deeper consideration to?
This CCSK exam preparation course will focus on an additional 12 domains of competency. These 12 domains fit into two broad categories: governance and operations. Governance, of course, focuses on the broad strategic issues and policies of the organization. Operations focuses on the tactical security concerns and control implementation. The governance related domains address the ability of an organization to govern and measure the enterprise risk introduced by cloud computing, potential legal issues that arise when using cloud-based solutions, maintaining and proving compliance, managing data that is stored in the cloud, and establishing the agility to move from one provider to another by using interoperable and portable cloud applications. The operational related domains address the impact of cloud computing on operational processes, such as traditional security, business continuity, and disaster recovery. How to evaluate a service provider's data center architecture and operations. Assurance that incident detection, response, notification, and remediation are properly and adequately planned. Securing the data or the software that is running in the cloud and using secure software development methodologies. how to deploy and manage encryption and encryption keys to provide privacy, but also to ensure accessibility of the data, how to manage and utilize authentication, identity, and access control for cloud computing solutions. And finally, understanding the risks that virtualization brings to your cloud application. Cloud computing is an exciting, powerful, new way to provide access to computational resources and functionality. The next series of modules will help build the knowledge base necessary for you to properly secure your company's informational assets as you harvest the benefits of this new economical solution.